Hello, welcome to my tutorial on the behaviour of solids. So, brittle materials break suddenly without deforming plastically. If a force is applied to a brittle material, it won't deform plastically, but it will suddenly snap. So when the force gets to a certain magnitude, brittle materials are quite weak, if they have cracks in them. Ductile materials can be drawn into wires without losing their strength. You can change the shape of a ductile material by drawing them into wires or other shapes, and they keep their strength when they become deformed. So copper is ductile because it can be wires can be formed and its strength can be still retained. And malleable materials change shape, but they may lose their strength, and they can be changed really easily. The difference between malleable and ductile materials is that malleable materials won't necessarily keep their strength. Golden is an example of malleable material, and you can change the shape of a ring using your fingers. So hard materials are very resistant to cutting, indentation or abrasion, and they have a strong structure. Diamond is the hardest material there is, and they have a high resistance to bending and stretching, the stiff materials, and changing the shape of stiff materials is difficult because they resist bending or stretching. Stiffness is measured by the Young modulus, more on that in previous tutorials. Tough materials are really difficult to break, and they're a measure of energy and how a material can absorb it before it breaks. Some polymers are really tough, including certain types of polythene. So it's just knowing about all the different types of words: brittle, ductile, malleable, hard, and stiff, and tough. The way the examiners want you to understand them is how I've written them up there. You don't have to necessarily remember the examples, but just what the words mean according to Edexcel AS Physics. The nice StressStrain graphs now, and we'll talk about that for a bit. Before point A, the graph is a straight line through the origin, and it shows that the material is obeying Hooke's law. This should be a straight line, not a curve like I've done, a straight line to show proportionality. So at point A, this is where the limit of proportionality occurs, and after this point the wire stops obeying Hooke's law, and it still returns to its original shape if the stress was removed. Point B is the elastic limit, and at this point the material starts to behave plastically, and from point B onwards the material no longer returns to its original shape when the stress is removed. And at point C, the yield point occurs. The material suddenly starts to stretch without any extra load, and it's distressed when a large amount of plastic deformation takes place with a constant or reduced load. So we'll now look at some questions, and we'll round off the end of the tutorial. So, which of the following best describes a material that can be easily shaped without losing its strength and it's resistant to tearing? Ductile, stiff and tough, malleable and hard, malleable, ductile and tough, or malleable, ductile and stiff. Hardened steel is hard. Brittle form is steel by making it heat up slowly and then quenching it in cold water. Write down one application in which hardened steel could be used and explain why it would be useful in this context. Riding helmets are designed to protect a rider's head from injury should they fall off their horse. Describe 3 properties of a material that would be suitable for a riding helmet. Explain why each of these properties is advantageous. So I'll give you about 5 to 10 minutes. Pause the video and have a go at the questions. Okay, so hopefully you've had a go at the questions. And now, the material for question 1, the material isn't stiff because it can be easily shaped, which rules out A and D, so it must be ductile because it keeps its strength when shaped. So the answer is C, malleable, ductile and tough. And number 2 is 1 mark for any sensible point, and then 1 further mark for an explanation of the properties of hardened steel. So sensible use would be a cutting instrument or an iron or an iron poker for your fire. But anything that is used to reinforce or toughen an existing material. The material would need to be stiff so that it would keep its shape and not crush the rider's head when forces applied to it. It would also need to be tough so that it could absorb the energy of an impact without breaking. It would also need to be tough so it could absorb the energy of an impact without breaking, and the material should be lightweight and comfortable. So that's it for the questions for this tutorial. I apologise for it being so short, but needing to know the definitions is very key to this particular part of the course, and there's nothing really I can do to make it more exciting. If you get the CGP revision guide, however, it's very, very useful in order to put definitions to you. So I highly recommend buying that. Thank you, and thank you for watching this tutorial.